Hey y'all, it's that time again. It's math with Mrs. Peters, the crazy cat lady of Hiram High School. Today, we're going to talk about sequences, but we're going to talk about another way of writing the formula. Up until now, we've talked about the explicit form, which looks a lot like a function, okay, with the x and a y type situation. We could graph it. Now, another way of looking at sequences is called a recursive sequence. Okay, it's a formula. It just helps us describe what's going on with our sequence. Okay, the word previous means the one that comes before. All right. Recursive means a formula used to find the next term of a sequence when the previous term is already known. Okay. In this case, a sub n is the term we want to find, or the next term, and a sub n minus 1, and this is notation right here, okay? That is not something you use to calculate any more than we use this to calculate. That's no calculation with that. So a sub n minus 1 means the one that came before, okay, before the one a sub n. Okay, so that's actually the term that we currently have, or the previous term. Okay, I know that's confusing, but we'll get into it. Just make sure that you know, in this case, that a sub n minus 1 is the term to the left on our sequence, and a sub n is the term to the right. All right, now let's look at this. We have two types of sequences we talk about. We talk about arithmetic sequences that have a common difference, and we talk about geometric sequences that have the common ratio. And remember, we can do a Johnny Bravo to determine what the difference or the ratio is. Now, a sub 1, a sub n minus 1, I just told you, is the previous term. This is the one we have. Okay? And a sub n is the term we want to find. And that's true over here also. Okay? A sub n minus 1 is the previous term. This is what we have. Okay? And a sub n is the next term, or the term we want to find. Okay, so let's look at a sequence. And here's a sequence right here, written in a recursive formula, with this being, okay, the term we have, and that's going to be the number 1. Okay? And I need to know, is this geometric or arithmetic? And how do we know this? Well, I'm going to know this because I'm going to look at this particular situation, and I'm going to notice that I'm subtracting 2. Okay, well, subtracting 2 means that I'm doing arithmetic, adding or subtracting, because this is addition or subtraction, and it is happening to the previous term. Again, this right here is the previous term. Okay, so if that's my previous term is 1, so my 1 is going to replace this whole piece of notation. I'm going to do the calculation of 1 minus 2, and I get negative 1. Now I'm going to use that term to find the third term. Remember, a sub 3 is the third term in my sequence. So I'm going to replace this a sub n minus 1. I'm going to replace it with this answer is going to go in here. And that's going to be negative 1. So now I can find my next term, which is going to be negative 3. And I could continue. A sub 4 would be negative 3 minus 2, because that's this minus 2. And that would give me negative 5. This is what we already did when we first started exploring sequences. So the next two terms, negative 1, negative 3, and guess what? I found and negative 5. So I could say my next 3 terms. And I bet you could find the fourth one and the fifth one and the sixth one and the seventh one because y'all are brilliant. I love it. Okay, now let's determine, is this sequence, okay, is this sequence arithmetic or geometric? And I'm going to note I have multiplication happening right here. And I want to make also that you pay attention that this right here, okay, that's a number that talks about the one that comes before. Remember the one that I have? Okay, and I also want you to notice that in this particular formula, there's not an exponent. In our explicit formula for these type, we have an exponent. In our recursive formula, we do not. And we are going to start with 320. Okay, and it tells me right here, my first term is 320. Now, we know that this is geometric because there is multiplication of -1/4 and that it is happening to the previous term, and that would be a sub n minus 1. Okay, now, what am I going to replace inside these parentheses? Well, I'm going to put 320. It's going to come down here and hang out in this little box. Okay, and then I'm going to multiply -1/4 times 320, and I'm actually just going to pop on the box because I already have it figured out. It's -80. Then I'm going to take -80 to find the next one in my sequence. It's going to come down here and live in this little box. Okay, and I'm going to do my, I don't know what the problem is here. I don't know why I have that down there twice. And I'm going to do my multiplication, and I'm going to get +20. So the next two terms in my sequence are -80 and +20. Now, if I wanted to find the fourth term, it would be a sub 4 equals -1/4 times +20, because that would be that 20 coming down, and that would give me -5. So my term after 20 would be -5. And we could go on and on and on. We just have to do constant work to find the next term in this case. And that's what we were doing when we first examined sequences versus the explicit formula, which mimics a function, an exponential function, that's the one with the exponent in it, or a linear function, that's the one that has the common difference. That said, y'all are brilliant. I know I've got a worksheet for y'all to work on. And, oh, hold it. We got 2 more problems to do. I just realized that. Oh, wow. Let's go look at them. Because I know y'all can do these. You try this. What type of sequence is it? Now, remember, even though I have values of x over here, okay, this is my domain. Okay, my domain is always going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 when I'm talking about a sequence. Now, you tell me what the right answers are for here. Okay? You can do this. You can give me the recursive rule for this formula. Because the recursive rule looks like this, and you've got to determine if it's addition or subtraction we're doing. So we know if it's, I'm going to tell you right now, it is arithmetic. It's arithmetic. But you've got to tell me why. You got to fill this in. You got to fill this in. You need to fill this in, and you need to fill that in. And you've got one over here, because you know Mrs. Peters, she's going to give you one of each. Okay, this is still a sequence because my domain starts with the number 1 and is counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, wherever. So that means, and I'm telling you right now, this is geometric, but you have to tell me why. And then you have to tell me what the rule is. And you have to tell me what the next term is. And you need to use this formula and do or simplify the formula if possible so it looks a little bit cuter, you know how it is. But y'all can do this. Okay, get those done, and that's what I'm going to check for when I check for homework tomorrow. So y'all take care, do this. I know you can. Y'all are brilliant, and we'll work on problems in class. Y'all take care. Love you guys. Bye.